Dan's point, every year we do plan to address the country frameworks. Antigua and Barbuda may have plant genetic resources as a priority, but when it's discussed at the sub-regional level, they would not address Antigua and Barbuda alone. So there is where we have to work, Carla, Rohan, Haiti, Cuba. If they have more than one countries, it would be easier to fit into the programs. So I think we have our work to do too.
Muy buenos días, les damos la bienvenida.
Good morning. We welcome our colleagues and the different participants that are accompanying us in the second day of this workshop. The workshop of taking action for biodiversity in food and agriculture in Latin America and the Caribbean. I apologize for the delay in starting the session, but we had some problems, climatic problems that we had to take care for, and also technological problems. So let us begin with the first presentation, which will be done by Sergio Salva. Thank you for being here with us to share your knowledge some early on. So please share your presentation, and you have 15 minutes. Good morning. Thank you. Do you see my presentation? Is it okay?
¿Se ve?
Vemos la presentación, Sergio, todavía no te escuchamos.
We don't hear you, Sergio, but we can see the presentation. We can't hear you, though. I'm talking now. Yes, now we can hear you. Okay, perfect. Thank you. Good morning. I will begin my presentation with this image. Here we see the landscape that is covered by yellow flowers. These are two flowers, Spanish retama and French retama, but this picture was not taken in Spain or France. It was taken in the Pampa region in Argentina. In a natural protected area, it is a provincial reserve that is devoted to the preservation of these fields. This is biodiversity in Argentina, and these plants have taken over the landscape. Who planted them? Nobody. These are species that sometimes were introduced in the country because of landscape issues and their ornamental value, and they moved ahead beyond the areas where they were planted, and they are established in natural and semi-natural areas. They modify the structure of wild species or native species, and they modify the intensity of fires and also change the nutrient cycle, for example, the nitrogen cycle. And this is what we call exotic invasive species, and this is the topic of this presentation. Throughout the presentation, I am going to focus basically on these four questions: the definition of exotic invasive species, the scope and the importance of their effects, particularly the effects they have on agriculture and food in our food security, and what are the alternatives that we have in order to confront this challenge. Regarding the definitions, there is a framework that is the Convention on Biological Diversity, which defines invasive exotic species as plants, animals, or microorganisms that are moved by people from one place to the other beyond their historical distribution boundaries. And once in the new environment, they can multiply by themselves, and they cause impact on the environment, the social values, and economic values. And somehow these are species that threaten the biological diversity, and this is a key point in this definition. The exotic invasive species are a problem because they are a factor that endangers the preservation of biodiversity. So the framework of the Convention on Biological Diversity establishes very important to promote the preservation of diversity, to foster the sustainable use of the components of biodiversity, and also the fair and equitable participation of people in their benefits. The invasive exotic species are a problem, not because they are exotic and not because they come from other places, but basically because they are invasive. And they can oppose one or more of these objectives. So the issue of these invasive species, it is not an issue of nationalism or chauvinism that is opposed to animals or plants coming from other regions, but rather is to focus on the preservation of our diversity. And this is a core issue because many of the species that we use to provide food in agriculture and also in fisheries, these are species that come from other regions, and a few only behave as invasive. Very recently, last week, the Intergovernmental Platform on Biodiversity issued a report on the state of the problem. And there are some figures here that are quite recent. For example, what you see here on the screen. It is calculated about 37,000 exotic species that have been introduced to new ecosystems and established their new populations that are self-sustained. About 10% of them have negative impacts on nature. And also, this movement of species is being intensified, and every year 200 new species appear in different parts of the region, and more than 2,300 of these species affect the soils of indigenous peoples throughout the world. Specifically, the invasive exotic species are moved by a receptor biological community in times that are basically instantaneous. The humans transfer animals, plants, and microorganisms, and we take them where the biological diversity is not prepared for that contact. So these exotic invasive species threaten biodiversity, and we know that this is one of the main causes for the disappearance of 60% of the plants and animals that are considered as extinct globally, and one of the most important threats for vulnerable species in the different countries. But beyond the species, the effect on the species, that is to say, on the plants and animals like predators, competitors, pathogens, parasites, there are species that can modify the way in which full ecosystems work. For example, like the beavers in Tierra del Fuego, and also with trees in the areas of prairie lands in the continent. And the arrival of these species implies an increase in the frequency and intensities of fires. These species are like engineers of ecosystems, and they directly modify the rules of the game, the way in which the full ecosystems work. So this is one of the most important challenges for the preservation of biological diversity, but their impact is not restricted to environmental effects, but they also represent a global economic loss. This report that I mentioned and was issued last week calculates that invasive species cause a global loss of more than $433 billion per year. And this is such a large number that is difficult to imagine. So to make a comparison, I'm going to comment that this represents more than 100 times the global budget of the United Nations for 2023. So this means that the cost of this biological invasions is not twice or 10 times, it's 120 times more than the budget of the UN for this year. And these costs are quadrupling every decade since the 70s. So rather than stopping the problem is becoming more significant. In 2019, within a project managed by the FAO in Argentina, they did a calculation of the losses nationwide for a set of representative species. And this species that you see here in this picture, which is the boar, and it is its origin is Europe. This causes a loss of $1.3 billion per year in Argentina. So for our economies, these are very significant figures. In Argentina, this is, for example, like 4 times the budget that the country destines to science and technology. This is only one of the 700 species that are cataloged as exotic invasive species. But besides the economic impact, biological invasions are a challenge for our health systems. We'll have a presentation about this concept of the relationship between environmental health and human health and animal health. There is a presentation of Alicia Gallardo about this. So these invasive exotic species are associated with most of the emerging or re-emerging diseases that are a gigantic challenge globally. And also, as you can see this in the picture to the right, biological invasions threaten our cultural diversity, specifically in our region's countries. Biological diversity. Specifically, the invasive exotic species have a direct relationship with agriculture, aquaculture, and forestry production. And this relationship is a two-faced coin. On the one hand, many of the species that affect production, for example, weed or pests in general, are species that have been brought from other regions, and many of them also affect biological diversity. On the other hand, agriculture, forestry, production, and aquaculture are amongst the main activities responsible for introducing species that in the end cause an impact on biological diversity in the introduction and dispersion of those species. The problem that this is an aspect that has not been considered conveniently when we want to move species from one region to the other. Maybe one of the great challenges of this problem of biological invasions is that it is a problem that is not as obvious as others that affect biodiversity. If you look for news in the media regarding biological invasions, it will be difficult to find. But maybe if there is a fire or if there is an oil spill in some coastline, that will be a topic that will be presented in the media of all of our countries. So what happens when contaminants don't travel in an oil tank or are not produced by an industry, but rather they are plants, animals, or microorganisms that we move from one place to the other? Well, it is not only less considered, but it has a side that is very serious because biological invasions are persistent. Fires stop. The contamination problems, if we apply the necessary effort, can also be mitigated or compensated, but invasions and the species that come from other places that affect our ecosystems, they arrive and they stay there. And also, it is common for exotic invasive species to be perceived as something positive by a sector of society. This card that you see to the left is in Tierra del Fuego in Argentina as part of the development of the national strategy on exotic invasive species. And this marked where we were working in the control of beavers. The beavers were introduced in 1946 in Argentina, voluntarily by the national government, by the government of Argentina, to incorporate them as a resource, an extractive resources. But finally, they are a significant threat for the forests there, both on the Chilean side as well as the Argentinian side. So this poster was intervened by people who were against the control of the beavers. And here there is a core issue. As I was saying, biological invasions are a great communication challenge. And somehow they are one of the last frontiers in environmental communication and education. So it is a great challenge to convey that these organisms that we move from one place to the other can end up causing significant impacts on the environment. And here we have something that is very important, because when we have a threat and it's not evident, that is not recognized, we have a double threat. And here we have data from this intergovernmental platform that says that 83% of the countries worldwide don't have laws or regulations directed specifically to prevent and control invasive species. And almost half of the countries don't invest in the management of these invasive species. This is a point that is important for those who work in the relationship between agriculture, forestation and biodiversity. The first step to confront this challenge is to recognize the risks associated to the movement of species from one region to the other. So what can we do in this challenge, which has a significant scope and is increasing and causes significant impacts? The first thing is to learn from what we know so far. And there is a lot of knowledge regarding how the invasive species behave when they arrive to a new territory. In this graph, I'm going to represent how the abundance changes in the area and also in the number of organisms that arrive as time goes by, from the point of introduction or the moment they are taken to the new territory onwards. And this curve could represent more or less this increase in abundance and in the covered area throughout time, from the late phase of growth to a faster period, and there's a flat period which has to do with the limits that the environment poses to these species. The different phases of the progress of these invasions are associated with an increase in the difficulties to management and also the increases in the cost of these controls. But there are actions that are very appropriate for each of these phases in this invasion. When the species are rare and when they occupy small territories, this is where the possibilities of eliminating this problem are higher. And as the number increase or the distribution increases in a territory, the contention or reduction of these abundance is more appropriate. And finally, when the species occupy large areas, usually the strategies that are more direct strategies are the strategies to minimize the impact of those species so that they can live together with the native ones. So to the left, in this, there's an arrow that talks about the introduction area, and this has to do with the prevention. Prevention clearly is the most appropriate alternative from the point of view of the effectiveness in the use of resources, and also to generate significant changes in the management of invasions. Everything that we can do to avoid the introduction of a risky species is something that we can win, and everything that we can use to detect this invasion early on is amongst the priority areas. So to think about prevention, it is important to understand how these exotic species arrive into a new territory. Some are introduced accidentally, others are introduced voluntarily, in some cases requesting the corresponding permits, but in other cases illegally. They are introduced with an objective associated to production. For accidental introductions and for voluntary introductions without permits, the ideal tools are the border control tools that have to do with the interception, decontamination, and the identification and management of vectors of these physical pathways that transfer those species. For voluntary introductions that do request authorizations, there are tools which are the risk analysis systems. These systems, risk systems, are tools that evaluate the possibility of an introduced species to escape from this crop area or from those spaces where they are grown, and it analyzes the possible risk if they can establish in natural environments. And finally, it takes into account their greater or lesser possibility to control them. So this creates a risk ranking before the introduction, and this guides the decision making. The QR codes here that are in this slide to the right, to the top, They correspond to two tools that were developed as part of the strategy on exotic invasive species in Argentina and were approved in 2019 by the Ministry of Environment and Sustainable Development. And these are tools that can help to develop similar systems in other territories and other countries. And the purpose is to guide the decision regarding the introduction of a species or not. Because here we have an important issue. We need, as a society, to move species from one region to the other for different purposes. The risk analysis systems are not to prohibit the movement of species, but rather to avoid the movement of high-risk species and to allow the movement of safe species that are important for production and other human activities. So what happens when prevention fails? The next thing is to try to act when the species are not in abundance and manage the species that are already present in the territory through the regulation of those species that imply some risks. As I said before, many species are important for production and at the same time they represent a threat. The issue is that in most cases, the problem is not at the species itself, but what we do with that species. In Argentina, we say is that the blame is not the one that does things, but the one who feeds things. So what uses do we give those species and in what territory? So there are different tools that include the regulation and the best practices and the voluntary codes of conduct and the official list of exotic species that are potentially invasive. This QR code is an access to the official list of exotic invasive species for Argentina, and it can help as a guideline for this step that is important to put a name and surname to the problem. Which species should be handled carefully, acknowledging that they are associated to a risk. And to finish, we need to remember this important premise. To manage invasive species is not an end in itself, but it is a way to preserve biological diversity, to promote the use of this diversity for sustainable development and the access to all the benefits derived from that biological diversity. Thank you very much.
Thank you, Sergio, and thank you for sharing the information. It was impressive. And now we will listen to John Barney.
John, please. Would you share the presentation? John, yeah.
Ok, muchas gracias por invitarme.
Thank you for inviting me,
Agradezco la oportunidad de compartir mi
and I thank the opportunity of sharing my work on soil biodiversity, but I will speak in English because my Spanish is very limited.
I'll do it in English if that's okay. So I want to start off with a quote. There was an American storyteller who said that mankind, despite all of his artistic pretensions, his sophistication, and his accomplishments, owes his existence to a 6-inch layer of topsoil and the fact that it rains. And so there are a lot, and we've discussed a lot, but there are a lot of ecosystem benefits that come from our soils. We rely so much on our soils. I loved the last presentation where they talked about how many billions and billions of dollars come from our soils without us even knowing it, without us recognizing the value of those soils. One of the things that concerns me very, very much is the fact that right now 1/3 of the world's soils are degraded. And if we don't do something about it, it could be up to 90% of those soils could be degraded by 2050. And that's if we don't do anything about it, if we don't take some kind of action. So what I've done here is I've taken a map of, so on the right, yes.
Sorry for interrupt you, but we are just watching a black screen. I don't know if you are sharing something.
Oh, Okay. Let me try and
Okay.
this is not sure why it's try it again here.
Yeah. Now it's okay.
Okay. Okay. Can you see this screen?
Yes.
Okay. So this map on the right is showing basically where those degraded soils are. And then on the left, I've placed a couple of maps of where some of the 4 major staple crops of the world are. And you'll notice that there's quite a bit of overlap between where our crops are growing and where the soils are most degraded. And so the soils that we depend on most as a civilization, as a world, are the ones that are most under threat. And so this is definitely not a sustainable type of opportunity that we have before us. So we're very much challenged. One of the problems that we have with looking at sustainability with soil health is that there are 3 pillars to soil health. There are the soil physical properties, the soil chemical properties, and the soil biological properties. And for decades, we've been looking at physical properties and chemical properties, doing soil maps, doing soil surveys, doing all kinds of efforts to really understand soils. But one thing that has been missing from all of this is looking at the biology of the soils. And so one of the things that we do need to realize is that soil is alive. We've been showing this slide for some time now that shows that soil is home to more than 25% of our planet's biodiversity. And I've got a citation down here at the bottom that suggests that we need to update this slide, because now it says that soil is home to up to 60% of our planet's biodiversity. And so there's a very much a strong foundation of life within our soils. Again, we owe our existence to that top 6 inches of topsoil and the fact that it rains. So the above ground biodiversity and below ground biodiversity are linked, very much so. And so as we start to look at what's happening below ground, we can start to see how it impacts above ground biodiversity. I've got an image here that shows that about 80% of the plant species are symbiotically linked with microbes. And I've limited that to very tight symbiotic interactions. And so, for example, rhizobium in legumes or arbuscular mycorrhizal fungi. So this isn't even considering just the beneficial interactions between plants and microbes, which we have seen quite a bit of. And so one of the most important things that I want to point out is that as we start to look at, especially with soil biodiversity, as we start to look at soil health, soil organic carbon, sustainable practices, conservation, biodiversity, all of these are linked. And so as you do one of these things, you're impacting the rest of these things along this chain. And there are a lot of actions that can be used to benefit the soil biodiversity. And one of these links that has come to light most recently is soil organic carbon. We talk about this a lot with the nexus between, biodiversity and climate change. Soil is one of those critical points, and studying the soil organic carbon and the potential of soils to basically be a sink for carbon. We see that up to 60% of the soil organic carbon comes from dead microbes. And so as we place more emphasis on the biodiversity, then we're starting to put more into soils, and we start to be able to better regulate climate change. And so really, you know, that's why I like that quote so much, going back to that 6 inches of topsoil and the fact that it rains. If we focus on the soil, if we really bring back the health of soils, then it solves a lot of our problems. It takes care of it will take care of us. So one of the things that we have started to try to encourage is to make sure that soil biodiversity is considered a part of soil science. So you saw that initial slide where we have all of the soil physical properties, we have the soil chemical properties, but we don't have the biodiversity in there. We need to put biodiversity in with those so that when we're doing soil surveys, when we're doing soil mapping projects, that biodiversity is included in that we're actually looking at what does that biodiversity look like. And as what was mentioned in some of the breakout sessions, as part of a monitoring program as well. So this is the kind of the scope that outlines some of what I do. And there are really 2 aspects that I'd like to focus on moving forward. One is the International Network on Soil Biodiversity. So that network is basically the intellectual backbone of what's driving us. So this is people, this is people like yourselves, stakeholders, policymakers, all that are interested in soil biodiversity. This is the brains behind it. This is the community, the network. And then the second part of it is this the Global Soil Biodiversity Observatory. This is what we're trying to accomplish. We'd like to put together a list of indicators, measurements that we're collecting, places that need to be observed and measured, and then incorporate that with building capacity, with training individuals, so that we can actually start a monitoring program across the world, and that countries are then starting to use the same indicators, that they're using the same measurements to look at the biodiversity, so that we're able to do global maps of soil biodiversity. Currently, there are a lot of initiatives that are going forward where we are looking at biodiversity, but those are usually at a regional, national, local levels. And a lot of times they're not using the same measurements. And so we can't really bring those together to make a global map to compare those. And so I want to step back and give a plug for this international network on soil biodiversity. There are 4 working groups right now. And the first working group is looking at measuring, assessing, monitoring. So this is really kind of trying to figure out what are the most important indicators of soil biodiversity. It's starting to look at how do we measure those indicators, and can we standardize or harmonize those indicators so that everybody is measuring those in a comparable way. The second working group is looking at what are some of the practices that are involved with improving soil biodiversity, improving the soil health. How do we implement those practices, and how do we implement them in an economic way? So there are a lot of things that we could do that would benefit the soil, but a lot of times, as we've discussed throughout these meetings, it's not economically beneficial for the farmers, and so we need to take that into consideration, which is kind of where the third working group comes in, looking at what are the economics involved with soil biodiversity. How does it benefit the grower? How does it benefit society? And how does it benefit the government, the countries that are implementing or trying to push forward these sustainable management practices, which then feeds into that fourth working group, which are those policies. Which ones are working? Which ones actually benefit society and are being adopted or used by growers? And how is that benefiting society and benefiting us globally? So I would like to have as many people as we can involved with this international network on soil biodiversity. So for short, it's called NetSob, for the International Network on Soil Biodiversity. If you or any of your colleagues are interested in soil biodiversity, I would encourage you to basically just type this into your search engine, and you should get to the Global Soil Partnership page, where you're able to get onto technical networks and find the International Network on Soil Biodiversity, or NetSob, and then you can just sign up. Right now, we've got about 800 members, and they're fairly evenly split between the first working group, which is measurements, and the second working group, which are the practices. We have a lot less on the economics and on policy, and then there are some that are just observers. They're just, I just want to be in the loop on what's going on with this network. And one of the goals of this network then is to put together this global soil biodiversity observatory, with the goal of looking at what is the prospect, it is a monitoring and an inventory of what is biodiversity look like in the world right now. And so it's really going to be at a country level. And so we're focused on helping individual countries to put this forward and implement this, building the capacity to do the measurements, to do the sampling, as well as the laboratory measurements to collect biodiversity measurements in the soil. And then the goal of this is to be able to provide that information to make those decisions, this decision making that can get into policy and can help farmers understand, which of these practices are really the best for my soil type, for my area, for my crop, whatever it is. What are those practices that are best for me to implement? So then it becomes more of a holistic, we're treating the whole thing rather than just trying to treat one aspect of soil biodiversity. So kind of as a summary of some of the things that we're looking for, is, we're looking to put soil biodiversity in soil surveys, into soil mapping, into all kinds of the conventional applications of measuring and looking at soils. We're looking at trying to get some bioindicators. What are the indicators of loss of biodiversity? What are the indicators of a healthy system? And then what are some of the practices that can improve the biodiversity? And we definitely need to focus a little bit more on some of the soil dwelling species. I'm working heavily with microbes, but from the presentations yesterday, there are a lot of solitary bees and things that live in the soils, and those would be part of measuring this biodiversity as well. So a lot of the pollinators are things that we're measuring, and so soil biodiversity covers a lot of the biodiversity that we are interested in. And so we're trying to figure out how to measure this and how to incorporate this in our measurements. And I think I'm just concluding with that our, that top 6 inches of soil, that's where a lot of life began. That's where a lot of the answers to many of our problems, I believe, exists, including genetic resources that are in the soils. Soil biology and biodiversity are key to soils. It's key to soil health, and it's something that we haven't measured as well as we should. And so because of that, we need to be measuring soils, or measuring biodiversity in soils. And it's all connected to soil health is connected to soil organic carbon, which is connected to climate, which is connected to water quality. So a lot of this is all connected together. And so I thank you very much again. I appreciate the opportunity to share with you all.
Muchas gracias, John. Muy importante.
Thank you, John. It is important to highlight the importance of soils and the biodiversity in soils, and also comment that in the Latin American region, we have a practice on soil treatment that has tried to position this topic. So maybe we're going to establish contact with the network you mentioned in your presentation. And also we have been working with the implementation of a program called Soil Doctors. So maybe we'll have the opportunity to emphasize those practices that are good for the soils. Thank you very much for your participation, John. Now we go to Alicia Gallardo, and she will talk about the approach of Una Salud. Can you hear us, Alicia? Yes, we hear you. Can you share your presentation?
Ya, muchas gracias. Bueno, primero que nada,
So we would like to thank Anna and the team for inviting me. It is an honor to be here today. And I would like to say, John and Sergio, that everything is connected. I am going to talk about animal health and human health that is connected to the species and also what is happening in the floor, the microorganisms that are there in the soil. So I would like to talk about the approach, One Health approach, which is the way in which we are preparing those who work in the health area to tackle the diseases with a holistic approach and an integrated manner. And in the case of marine animals, to care for the diversity. So what is One Health? One Health is the interconnection between human, animal, health, and for example, wild animals or production animals like livestock or aquaculture, and also the environmental health. This approach is important because it forces us to have a multidisciplinary collaboration. I was listening when you were talking, what you were talking about the teamwork, and this has forced us to move ahead and communicate with the colleagues in the area of ecosystem and also human health. So what has happened in time? Basically, we have had diseases and a lot of challenges in animals. We have the mad cow disease, for example, and also we have diseases caused by plasmids in the case of the yearly mortality of the shrimps, for example. So we have challenges that are more relevant and they are associated to the epidemiological triad. That is to say, what happens in the environment, what happens genetically with our microbial agents, and also what happens with the host. And we have an interconnection with the environment and the soil, because we have the plants there, what happens with agriculture, what happens with the waste of agriculture. Unfortunately, all of that has a meeting point, which is the coastal environments, the bays and the rivers. And what happens with humans? So, unfortunately, we have been challenged by diseases that you know, for example, COVID, zoonotic diseases that are very relevant. And we have had a change in the behavior of avian influenza. So we have had some prevention to take data and also to evaluate a possible pandemic behavior. And also we have the antimicrobial resistance. Our bacteria have always had a mechanism to generate resistance. However, this has exacerbated in the past few years because of the use of antimicrobials in the human area and animal area, etc. So bacteria, as John said, have a very interesting mechanisms through plasmids. And today we are talking about transformation, transduction, and there are genes of resistance in the environment, and they are transmitted through air. So the risk, as Sergio mentioned, is important to consider, not only as a unique risk or a single risk, but a multiple risk. So to tackle the issues of health of aquatic ecosystems and food security, because it provides high quality proteins, and according to the SOFIA report of 2020-2022, it's increasing, and this is the future of protein from here to 2050. Those who work in food security need to be responsible to produce this aquatic protein in a sustainable manner. So when we talk about environmental health, we incorporate everything that happens from the point of view of health and well-being of animals, and we talk about environmental health. This term has been worked on with the UNEP in an important campaign last year and this year to fight antimicrobial resistance. We are working with the FAO as an agency related to food security, the World Organization on Food Health or Animal Health, or the Pan American Health Organization representing America, and also UNEP that has helped us to observe this multi-risk environment. And this is important. These are figures that I took from the page of ONSA. 60% of the agents that cause diseases in humans have their origin in domestic and wild animals. So our role as veterinarians or as managers of risk in animals is key in order to prevent those zoonotic diseases that are relevant, for example, COVID. And more than 20%, and this is data that adds up to what Sergio said, 20% of the losses in animal production, which is the aquatic protein that we want to produce and create a transformation as FAO, 20% of the losses are related to animal diseases. So this is a great challenge to prevent these diseases, and if they occur, to take the measures so that they are not a risk for the ecosystem. Another important data is that human actions have altered 75% of terrestrial environments and 66% of the marine environments, which is what we're going to talk about in this presentation. And that diseases represent a direct threat to incomes of rural communities. We know that about 800 or 1 billion people in the world depend on aquatic protein that they produce in their communities. Therefore, the rural communities and coastal communities need to be responsible to tackle all these risks, and also to respect the indigenous peoples, as Sergio mentioned. Here we have an example, which is the avian influenza, and it's been here for a long time. We had several outbreaks in our countries in Latin America. However, we have seen a change in the hosts, as we have seen in the past year, towards some maritime mammals and birds. So this has created a great impact in Peru. It started in February of this year with a massive pelican death, and then other maritime birds, and in Chile, the penguin and also the sea lion. So there's an erratic behavior of avian influenza that affects the productive birds, but also it affects the wildlife. So the point of union between the food of the wild birds that are affected with avian influenza has been the way that this disease has disseminated throughout wild animals. We have seen, well, this is a publication of Peru, and Chile has also published it. This started in February in Peru, then in Chile, and we are seeing the first cases in Argentina and Uruguay a couple of weeks ago, and also Brazil. So this is already affecting maritime animals. So what is the impact this has had? I'm thinking about the diversity of our oceans. This is from August 2023 in Chile. Close to 18,000 animals have died In normal circumstances, we almost have 1,000 animals dead. So this is an evidence that the health of these animals is being affected. Unfortunately, we have not done laboratory analysis to confirm the viruses. Senapesca is publishing this, and this is important to monitor the situation in the different regions in where we observe this in different marine species. You can see here that this started in the north, close to Peru, but then it has expanded throughout the national territory. And we see that out of the 18,000 animals, 16,000 sea lions that have been affected. We have lost full colonies of these sea lions in Arica. 2,493 Humboldt penguins have been affected, also chungungos, marsopas, Chilean dolphins, and also otters. In Argentina, other species, and Uruguay as well, but we are going to meet, the ad hoc group will meet to do an analysis. We're going to have a seminar in Brazil where we will see the epidemiological situation of the disease. The sea lion, we told you that around 16,000 sea lions died. So we are talking about a census that Chile made through the research on fishery investigation, and there we saw a census of these individuals between Arica and Parinacota, so we can see the impact of the sea lion, and is classified as the Ministry of the Environment as a minor concern, and also the IOCN a minor concern. But I would like to state that the sea lion plays a significant role for ecosystemic services. Besides having direct evidence with the community. So this is a significant data. Here you can see the last census one. This is the information here. It's important to see how the population is being manifested and the impact of diseases. The Humboldt penguin is significantly distributed from Ecuador to the Región de los Lagos, and it is vulnerable for the Ministry of the Environment. And if you see the last census, they mentioned around 25,000 individuals. So if we make an analysis, we can say that between 10 and 12% of the population of Humboldt penguins in Chile has been reduced by this disease. So we need to evaluate this from the point of view of risk and impact so as to move ahead and establish mitigation mechanisms. What is important here is prevention. It is always better to prevent than to cure. So we are working in biosafety practices, that is to say, to establish the risks at the level of the maritime ecosystem, the land ecosystem, also in human health, so that we can mitigate those risks, the most relevant ones, so as to move ahead in early warning mechanisms, early detection, preparation before emergency. So this may be the key element in this situation. The key words are monitoring and early surveillance. Here we have the information available from SAG, and they are identifying the location, and this is important from the point of view of risk, and also the types of animals, both for animal production as well as wild animals. And this is very important information. This is a geo-referenced information that helps us see where the beachings are and to see what is the cause of this mortality. So as a summary, and this is a slide that we presented to a pandemic fund with FAO Chile, which unfortunately we did not win, but what we recommend for this situation of impact into animals in the maritime environment is to have early detection and surveillance of wild animals and coastal animals, and also the study of the cases. And here we are proposing participative epidemiology incorporating the community that lives with the animals. And maybe this is the great leap that we need to take. And then to communicate the risk. When we had the avian influenza in the north, I communicate to the directory of the Chango people, and they talked about the fear that they had. So communication is fundamental in order to work together with a common objective. Communication, particularly in the coastal communities here, we have the Chango people, and they have internalized the sea lions in their culture. Therefore, those peoples in other countries, for example, in the Pacific, they can be a good example of participative work and to raise information. I always say that the fishermen know the sound of the sea and they know what is happening, and we as an expert or advisor need to take this information and add it as a diagnostic value so as to arrive at a better conclusion in order to have early detection. Communities are very important, particularly because they have this input related to their culture, and it is important to communicate what is happening so that they take preventive measures if there is a disease that is arriving. So the key point is that we need to care for the health of our oceans. It's vital for global health. The One Health approach is the interconnection between human, environmental, and animals' health and requires the cooperation of several disciplines. The prevention of diseases in animals is a crucial step to protect biodiversity, and we are taking care of this through several tools in the FAO. We're working in land animals and aquatic animals, and it is important to have surveillance and communicate with coastal communities. So the message is that the prevention, particularly in marine animals, is essential not only for the health of those animals, but also to protect the maritime biodiversity, which is the lung of our biodiversity and what our future generations will receive. So thank you very much for inviting me, and it has been an honor to share with you. And this is a picture of the sea lions and the penguins that we return to their environment. Thank you, Alicia. And yes, the elements that you mentioned about prevention and surveillance and monitoring and for early detection, risk analysis, communication of those risks, health not only of the maritime ecosystem but of ecosystems in general that we have mentioned during this workshop, and the need to work on intersectorially apply to all, because we are an ecosystem formed by different systems that interact amongst themselves. So thank you for mentioning this connection. Now we go to the last presentation of the day. In this case, we have the colleague Ian Ngon, who will talk about the friendly practices with biodiversity, particularly pollinizers.
Thank you. So, as Anna said, my name is Hien Ngo. I'm very happy to be with all of you today. As I introduced myself on the first day, I worked with FAO during the first International Pollinator Initiative, and then I worked for almost a decade with IPBES. And the first ever product of IPBES was the pollination assessment, which was looking at pollination and food production. It was the first ever product from IPBES and first ever global assessment on pollinators. So today, I'd like to talk to you about biodiversity-friendly practices for pollinators. So it's a little bit lighter before lunch, but I would like to give some examples in Latin America. For the last couple of years, I've been working with Latin American countries, namely Brazil, Mexico, Peru, and Costa Rica, and I'll be giving some examples today. Before I formally start my talk, this has been said by Breno and Lucas and many others, but the vast majority of bee species are wild, including pollinator species, so not just bees. More than 20,000 bee species exist worldwide. But although bees are the most important group, we should not forget that flies, butterflies, moths, wasps, etc. are also important for pollination services. Jeff has laughed, so I feel comfortable saying this, but there's only a few species of bees that are managed, and apis, there's only 10 species of honeybees around the world, where a majority of them are in Asia. But you can see out of that 20,000 species, most of them are wild. For my homework yesterday, I looked up everybody here, and I looked up the most recent lists of bees present in your country. Now, as you can see from that list, obviously there's a knowledge gap. I fail to believe Antigua and Barbuda only have 3 bee species in their country. But this is the most up-to-date list of bees known for your country. And as you can see, the diversity is quite high for some of them. Again, the information is incomplete for a lot of the countries. St. Vincent and the Grenadines, only 31 species. I also find that hard to believe. But then you have very speciose countries like Mexico, high diversity. But my talk today, I'll just quickly talk about the drivers of pollinator loss, the current status and trends in Latin America, biodiversity-friendly practices as examples, and you've mentioned important crops in your country, including soybean, peppers, coffee, and then I'll talk a little about inclusion of Indigenous peoples and local communities, and then the future of FAO work. Threats to bee species include land use change, intensive agricultural management, pesticide use, environmental pollution, invasive alien species, pathogens, and climate change. We do not have a good understanding of how these stressors interact with each other to put pressures on pollinator communities. So that is also another big knowledge gap. I was part of a group of experts in 2021 that published in Nature regarding relative regional and global importance of 8 drivers of pollinator decline and their 10 consequences to human well-being. In South America, you can see that land use change and cover and management and pesticides are well established and important, and also GMOs there at the bottom. South America is the second largest producer of GM crops, which includes soy and maize. Risks were greatest in Latin America compared to other regions of the world. Pollinator deficits, yield instability, food system resilience, and wild pollinator diversity. This reflects the high diversity of insect pollinator crops grown and exported throughout Latin America, often by smallholder farmers in and around the areas of natural habitats which contain a high diversity of pollinator insects. This was a paper led by Leo Gallardo in Argentina, which reviewed the status and trends of pollinators in Latin America. It was very recent. You can see that the expansion of land dedicated to agriculture has increased since 1960 for both pollinator-dependent crops and non-dependent crops. You can see there that in 2016, soybean really took over, and that explains the large increase in pollinator-dependent crops, which is in red there. In 1961, soybean only accounted for 0.4% of the total agricultural land in Latin America. In 2016, that percentage is almost 40% of the land. So North America and South America since 1960 has increased 900% in soybean production. Overall, we know that large-scale agriculture has decreased biodiversity in general, and pollinators are not an exception. So I mentioned huge knowledge gaps with the interaction of stressors on pollinators. This is the annual pesticide application more recently in 1990 to 2018. As you can see in South America, it is increasing. Also in North America and Europe, the trends are also there. This is using FAO information. So combining land use change and pesticide use, South America is very vulnerable to biodiversity loss and pollinator loss. Last year, FAO held a series of workshops in Latin America with a number of stakeholders, hundreds of stakeholders. Some of you were involved in those workshops, but we discussed pollinator-friendly practices. I'm not going to read this whole list, but I would like to draw your attention to some pollinator-friendly practices for involve managing for nesting sites. And I'll just leave that there for a second. Some biodiversity-friendly practices involve helping forage for pollinators, like leaving flower-rich field margins, increasing mixed crop types, etc. And you also mentioned within those workshops that the reduced use of chemicals, organic agriculture, selective weeding were biodiversity-friendly practices that could be applied in your national circumstance. And then Breno on the first day talked about managed pollinators, alternative managed pollinators to that of honeybees, although honeybees are very important. So what are some real examples of biodiversity-friendly practices in Latin America? So let's talk again about soybean. So soybean, of course, can be produced without biotic pollinators. But in a recent, not so recent, sorry, 2015 paper, biotic pollinators were looked at compared to fields of without excluding them. Sorry, including nesting substrate. I would like to draw your attention that nesting substrate just meant clearing a patch of 1 to 10 meters, 1 meter by 10 meters for ground nesting pollinators. And the result was that there was an increase in yield of soybean and an increase in ground nesting bee abundance. So just clearing some land in the center of your farm can increase pollinators and increase productivity. We heard that last talk from John talking about the importance of soil biodiversity, which includes ground nesting bees. Well, this was a study that showed that ground nesting bees are important for soybean productivity. I like this study very much. It was done in Brazil. So another important crop is bell pepper. And this study actually asked the question of if we include basil and we intercrop it with bell pepper, how does that impact pollinators and how does that impact production? Basil is a crop species that you can intercrop that flowers all year round. So both richness and abundance of bees was higher in intercrop sites and peppers in intercrop sites had higher quality, including bigger, wider, heavier, and more seeds. So that is a win-win just by adding basil. And my favorite crop of study is coffee, not only because I drink a lot of it, because I studied it in graduate school. So this is 2 studies done and can be applied in Latin American countries as well. So we know that from studies done in 2003 that Arabica beans can see an increase in production by 12.3% with bee pollinators. And we note that diversity, not abundance, explain the variation, meaning a diverse population of pollinators is important for coffee. In a second study in Costa Rica, they found that forest fragments can support pollinators and pollination up to 100 meters away. So bee richness, overall visitation rates, and pollination deposition were increased by having a forest fragment nearby. These are all biodiversity-friendly practices that can be applied within your own national circumstance if all parties are willing. Many times throughout this meeting today and yesterday, it was noted that the importance of inclusion of Indigenous peoples and local communities were noted. Traditional and local knowledge is prevalent in Latin America, and it's dating back to 1400 years ago, for example, in Peru. With our work in pollinators, we should always include the participation of all relevant actors, including Indigenous peoples. Last year in November, I visited Peru with my work at FAO, and we talked to the BOA Reserve in Oxapampa, and we made sure that we talked to stakeholders that were there and local communities that had invested in pollinators and pollination issues. So my second to last slide, I would really like to emphasize some take-home messages. There are many knowledge gaps regarding pollinators and pollination services, as we know. Both wild and managed pollinators are important for the delivery of these pollination services to important crops. Diversity is key, not only in pollinator communities, but also in systems and landscapes. Increased heterogeneity really increases the resilience of systems. This is a new paper we are working on, linking pollination to SDGs. And many of the SDGs and target 7 actually of the Global Biodiversity Framework in particular cannot be achieved without good protection and sustainable management of pollinators. So our paper found strong links between SDG 2, Zero Hunger, SDG 15, Life on Land, and SDGs 1, 6, 8, 10, and 12, which are regarding no poverty, responsible consumption and production, and clean water. My last slide is really about the continued work and dedication of FAO to this topic. So we continue to work leading and facilitating the implementation of the Plan of Action for the International Pollinator Initiative, which is a decision under CBD, Decision 14.6. We continue dialogues with stakeholders regarding priority actions. Next month, I'll be going to Guadalajara to attend the Mesoamerican Congress on Native Bees. And we want to build capacity with virtual courses regarding pollinators and pollination and a lot more in the future. Thank you very much for your attention.
Gracias, Ian. Vinculando los temas que se trataron en las 4 presentaciones, básicamente el tema del impacto que
Connecting
tiene
the themes in the 4 presentations concerning the types of practices, use of the soils, the discriminate use of agrochemicals, and managing exotic alien species. A comment from the chat of the 300 persons that are following us virtually regarding the impact of having access or not having access to policies on biodiversity. Also the theme of political will, its importance for dealing with these topics, and also the importance of having professional profiles that can provide services to this type of actions that are required for addressing the themes in a holistic way, and also the new risks that we are facing and the new realities. So this is also part of what is coming that encompasses the need to address these themes. Before closing, I'd like to comment that in the chats of the different networks that are helping us to transmit this workshop, a link has been shared. This link, you will have the different presentations of yesterday, of today, and also the recordings of yesterday and today, including the 8 presentations that we have listened very attentively. And so at this time, I will close this session. Thank you again to the panelists. Very, very, very excellent presentations from yesterday and today, and the persons who are following us in the different networks today and yesterday. So thank you very much. And surely we will be dealing with these, addressing these themes in the next incidents.